Hi guys, in this video I'm going to show you how to find the direction cosines as well as the direction ratios of a vector. So if you are new to this expert tutor channel, please don't forget to subscribe it. So here, before finding these direction cosines and direction ratio, first of all we need to know what's meant by that. It's the main thing is we need to calculate this for a direction vector. Let's say there's a direction vector in a 3D plane. So if you imagine a 3D vector, it have three axes, mainly x-axis, y-axis, as well as z-axis, which is come out of the paper, which means come out of this plane. So there are three axes. So what's mean by the direction cosines of this direction vector means it's going to denote a direction. So let's say it's going in this path. And please remember, I have only drawn in this 2D diagram, but just imagine as a 3D diagram. If there are three planes, three axes, we are going to measure the angle from each axis. For that angle, we need to find the cosines value, cos of each angles. The angles which are making the angle which I'm making between the x-axis, y-axis, z-axis with this direction vector. These are known as directions cosines. So as I have already mentioned, there are three axes, x-axis, y-axis, z-axis. So when we are considering about the direction cosines of a vector, there would be three direction cosines. For these angles, we need to find the cos value. So the main thing over here is, let's say we need to find the direction cosine for this vector. This is a direction vector. They have given the direction vector, which is 2, 4, 4. So the main thing is, the beautiful thing is, you can directly write the cosine, direction cosines directly using this value. How to find that is, you need to use this cos alpha would be equal to, let's say the alpha is an angle which is between the direction vector and the x-axis. So remember like this, if you are going to find the value of this cos alpha, the cos alpha would be equal to the x value of this one. This is if you consider as x, y, z, the x value of this one divided by mod of a vector. So you can directly find the mod of a vector. It would be equals to 2 over. So you can directly find the mod of a vector, which means the length of the a vector. So you can find by using root of 2 squared plus 4 squared plus 4 squared. So if you simplify this, you will be getting 6. So the thing is, when you are calculating this cos alpha, the direction cosine, with the x-axis and the direction vector, it would be equal to x value of the direction vector divided by the mod of a of that vector. So if you divide it by this, you will be getting 1 by 3. So this is a direction cosine of that vector, but remember, this is only one direction cosine. For a vector, there are three axes. We are going to consider in the three axes. So we need to find other two also. So you can easily find like this. Cos beta would be equals to the second direction, the second axis we are normally denote is y-axis. So this is going to be 4. And if I divided by the 6, the mod of a, it would be 2 by 3. After that, you can directly tell cos gamma, if the gamma is the angle between the direction vector and the z-axis. So if I mark it like this is all going to be same 4 by 6, which is 2 by 3. If you want to figure it out what's the plan and how we are going to derive this or how it's equal, you can watch any animated video on YouTube, so it would be very easy for you to understand. But the thing is, if you have a question like this, you can directly use this method and find this direction cosines. So if they ask about direction cosines, you need to find all three. But remember, you need to mention this cos alpha as the alpha is an angle between the x-axis and the direction vector. So likewise, you need to define for beta too. So when you are when you are answering for beta, you need to mention the beta is an angle between y-axis and this direction vector. So after that, they have asked about direction ratios. So when you are considering the direction ratios, it simply means the ratio between these direction cosines. So if I simply mark it like this, cos alpha, cos beta to cos gamma. So we need to find the ratio between these. If you figure it out, it's going to be, I think I have made a mistake here, over here, 2 by 3. So 2 by 3 is going to be 1 is to 2 is to 2. So this is known as direction ratio. So from that, the main thing over here is from this, you can find the direction vector, but the thing is you can find the unit vector of this direction vector. Actually, you can't find this vector directly, but you can find the unit vector of this direction vector using this direction ratio, which means if you know the direction ratios, you can directly write it like this: 1 comma 2 comma 2. It's going to be lambda times over this. If you know this direction cosines or direction ratios, you can directly like the direction vector like this. So this is a short way. If you remember, if you have anything like this, if you have given a data like this, you can directly use this formation. So I hope this video would be useful for you. If you like to watch any other video related to direction cosines as well as the vector questions, I have given the link in the description, so you can always watch that. Thank you for watching.